Welcome to another application of exponentials and how to solve an application problem using Desmos by graphing. So let's read the problem here. It says find the time in years required for an investment of $4,500 to grow to $6,750 at an interest rate of 5.25% per year, compounded quarterly. It says use the compound interest formula below here. And A stands for the amount in the account. P is the principal of the account. So A is the account balance. P is the principal. R is the interest rate. We write that as a decimal. And T is the number of years. So in this problem, we have an investment of $4,500, and that is the principal. It's supposed to grow to $6,750, and that would be the balance that we want it to attain. And then R is 5.25% per year would be 0.0525. And already the quarterly, the 4 is already there for quarterly there. And we're going to be solving this for T. So let's go ahead and write that, what that equation would look like. And that's going to be 6,750. And that is supposed to equal the principal, the 4,500, times 1 plus, now this is 0.0525 over 4 to the 4t power. That's a 0.525 there. That number didn't look too good. Oops. 0.525. That number. Now, let's put both of those into Desmos now. Okay, so we've got this. We can exit that drawing, and we know what those are supposed to be because we have them right here basically. So the y value, one of those is supposed to be 6,750. That'll be the first equation. And the second equation is that principal, which was 4,500, in parentheses 1 plus, now 0.0525 divided by 4, okay, and that is raised to the power. Now we'll put an exponent, and the power here we have to put in parentheses. It's 4 times, now typically they use x here, so I'll use x even though they use t in that. There it is, there's to the 4t power. So notice that with the scale that I have, it doesn't show up if it's really close, if it's kind of zoomed in. But if we zoom this out enough, we should start to see, well, yeah, there we see both of them. We see the black one at first, and then we see the red one. So maybe that's a little too far out. What are we really looking for? All we're looking for is just this one point of intersection. And now, typically Desmos will give us that point. If we go close enough in and mark it, it'll tell us what that point is. Just kind of come over and click on it, and it gives it right there. There's when x is 7.774, then the y value, that is 6,750. So the x value is the 7.774, and that's all we have to do. And we can just click on that and see, yeah, 7.7737. Well, it's just rounded off to the nearest thousandth, didn't it? So that would have been the correct solution. Pretty simple to do that. You just have to be comfortable using Desmos and know how to plug the values into the variables there. Okay, I hope you found this video helpful.